Welcome. We're going to continue to take a look at solving problems with ratio and proportion using modeling. And we're going to start by reading the problem and determining what the problem is all about. Here we go. The ratio of the number of bikers to the number of runners at a nearby park is 2 to 1. The ratio of the number of runners to skaters is 3 to 5. Well, it looks like there are two follow-up questions here, but before we read those, I want to actually model what's going on. We have a relationship between bikers and runners at a ratio of 2 to 1. So let's get set up. I'm going to make B, the letter B, represent the bikers, and R will be representing the runners. So we know that their relationship is at a ratio of 2 to 1. That means if I make a bar for the bikers and I split it into 2 units, then the runners will have a bar that's 1 unit long. Okay, now this is a three-way relationship, so we know how the bikers relate to the runners, and we're also told in the second half how the runners are related to the skaters. So I'm going to add the skaters in here. It seems that the runners to skaters are at a ratio of 3 to 5. So let's make a space for skaters. Now, here's the tricky part. 3 to 5, I don't want to add units to the runner bar, because if I add units, I'm changing the amount of runners there are. And there's the same number of runners in the park no matter what. What we need to do is we need to think about taking the unit that we've already used for the runners and making it into 3 units. The relationship between runners and skaters is different and would have different shared units than bikers to runners. So I'm going to actually split up the runner bar into 3 parts, and then I am going to make a bar for skaters based on these new parts. So I start with 3, and then I know I need to make 5. Now, at this point, some people ask me, well, how do you know that the skater bar should be smaller than the biker bar? You can see here that if we kind of imagine down, that the biker's unit bar is longer. And one thing I want you to point out is that if there are 3 runners for every 5 skaters, we know that there are more than half as many runners as skaters, and we know that the bikers have to be twice as many, which means the runners are exactly half as many bikers. That might be a little confusing, but this is going to help us pull it all together. All right, so let's go back to the question, because we started to model and now we're going to find out what we really have to figure out. Part A says find the ratio of the number of bikers to runners to skaters. Okay, one mistake that students make at this point is they say, oh, the ratio is 2 to 3 to 5. But we have to make sure that we're comparing the same units. You'll notice that the units represented for the bikers are much larger than in the runners and skaters, but we can use that to our advantage. Remember how we knew that 1 large unit for the biker was equal to 1 unit for the runners? Well, now we know that that unit is split up into 3 parts, and we can do the same division with the bikers. So I can break up each unit that the biker originally had into 3 parts. Okay, and when we look at it all together, I'm actually going to trace over this as 1 unit and trace over each and every vertical line. We can see that we have 1, 2, 3, 4, 5, 6 parts for bikers, and this will allow us to set up the ratio. The ratio for bikers to runners to skaters is the number of units, 6 for the bikers, 3 for the runners, and 5 for the skaters. And I'm going to make sure that I write that up here. 6, use my colon for the ratio, to 3 to 5. That means for every 6 bikers there are at the park, there are 3 runners and 5 skaters. All right, let's move on to the part B, the last part of our question. It says, if there are 25 skaters, how many bikers are at the park? If there are 25 skaters, how many bikers are at the park? This is where we're going to start identifying the unknowns and using the labeling that we've already had. We can label the skaters, and I'm going to move this up so I have more room, as 25. Those 5 units represent 25 skaters. And what we want to find out is the number of bikers, so I am going to label the bar for the bikers as with a question mark, because that's what we want to know. Now let's start to solve. We always go back to the problem and look at what we know about, what quantity we know, and we know that the skaters, there are 25 of them, and the skaters are represented by 5 units. So 5 units equals 25 skaters. If I divide by 5, that means that 1 unit, each of those small little bars, is equal to 5 athletes, 5 skaters. And if every little bar is 5, then if I go back to the bikers, there are 6. So we're going to take 6 units times 5 athletes per unit, and we get a total of 30 bikers. And it looks like we have solved the problem.